hexadecimal table. Why? Because that is very important. In the exam, you do one thing before you get the paper, question paper. Mostly, you will get kind of rough papers before the exam. So when you get the rough paper, do one thing, compile these two tables, because this is very important. You can easily answer two questions or three questions, maybe more than three questions using this table. So one is octal table, the other one is hexadecimal table. These are very important two tables. So these two tables are very important. So the first one I'm going to create. So this is for octal. So you know, in octal you have few digits. Octal you have 0, then you have 1, 0, 1, 2, 3, 4, 5, 6 and 7. These are the digits you are using in octal number system. There's a pattern, so you have to find out the relevant binary to this octal number. So this octal number can be represented in binary. Anyway, you know, this is 0. So what I'm going to do is I'm going to divide and show you. So 0 in binary, 0 bedanna ona deken beduwama remainder is 0. This is 0. 1 in binary, අපි කොහොමද ලියන්නේ? 1 එක බෙදනවා දෙකෙන්, එක දෙකෙන් බෙදුවම 1 divided by 2 is 0, remainder 1. Then 2 divided by 2, 2 divided by 2, the answer is 2 divided by 2, it is 1, remainder 0. So you write as 1 0. Then 3 divided by 2, it is 3 divided by 2, the answer is 1, remainder 1. 3 divided by 2, the answer is 1, remainder 1. You write 1 1. Then 4 divided by 2, 4 divided by 2, the answer is 4 divided by 2, the answer is 4ට 2 2යි 2, remainder 0. Again you divide this 2. දෙක ආයවා දෙකෙන් බෙදන්න ඕන. දෙක ආයෙ දෙකෙන් බෙදුවම එනවා 2 divided by 2, it is 2 divided by 2, it is 1, remainder 0. So you take from මෙහෙ ඉඳන් මෙතන ඉඳන් උඩට නෙවෙයි ගන්න. මේ පැත්තෙන් උඩට 1 0 0. 4 දෙකෙන් බෙදුවම 2යි ඉතිරි 2යි. ඒ දෙක 4 දෙකෙන් බෙදුවම 2යි ඉතිරි බිංදුවයි. ඒ දෙක ආයෙ දෙකෙන් බෙදුවම 1යි ඉතිරි බිංදුවයි. එතකොට ඔයා මෙහෙම අරගෙන මේ පැත්තට ලියනවා 1 0 0. Then 5 පහ දෙකෙන් බෙදුවම 2යි ඉතිරි 1යි. දෙක දෙකෙන් බෙදුවම 1යි ඉතිරි බිංදුවයි. Okay, then there was small disturbance. Okay, anyway, then 6 divided by 2, it is 3, remainder 0. Okay, then so we can calculate like this, but there's a pattern. So I just wanted to highlight that pattern first. 0, so take the last digit. You can add 0 to the beginning. I'll add 2 zeros, 1 0 here, 1 0 here to balance this. So then see the digits, it's interchanging. First one is 0, then 1, then 0, then 1, again 0, 1, 0, 1. Then double 0, double 1, double 0, double 1. Then 4 zeros, 4 ones. There's a pattern. So this is what I want you to see. So no need to divide, because there's a pattern in binary. Please write that according to the pattern. Then when you have hexadecimal, you repeat the pattern like this. Then you have 8, digit 9, then 10 you denote it by A, B, C, D, E and F, because A is 10, 11, 12, 13, 14, 15. Hexadecimal, you have digits up to 15. So altogether, this 15 forms these 15 digits forms the number system. So what you have to do is you have to repeat the same. I'll copy this. I'll copy this and paste. I'll copy this and paste. Then I'll add beginning zeros. And here also I'm adding ones. Right, now see the pattern. 0, 1, 0, 1, 0, 1, 0, 1. Last digit is interchanging, toggling. Then the second digit, double zero, double one, double zero, double one, double zero, double one. The third digit, four zeros, four ones, four zeros, four one. The fourth digit, eight zeros, eight ones. If you want to check whether this is accurate, you can just write B. B means A is 10, B is 11. 11, you divide it by 2, then the answer will be 5 remainder 1. Again you divide it by 2, then answer is 2 remainder 1, divide it by 2, then answer will be 1 remainder 0. You take this way 1 0 1 1 1 0 1 1, and B it is 1 0 1 1. You can check that is correct. The pattern is very important, so better write down this, then you can do things easily. So do this before the exam, do this, then you can do things easily. Why I'm telling that? If you have a number like this, okay, for an example, assume that you have number like CA9 in hexadecimal. They are asking you to convert this to binary. So easiest way is C means 10, C means 1100, A means 1010, 9 means 1001. You write the digits and this is the binary value. Write 4 by 4. You get the binary number. And if you are given an octal number 3, 4, 5 in octal, if you are given octal number, so what you have to do is you have to refer the previous table, which is this one. 3 means 0 double 1, 4 means 100, 5 means 101. 0 double 1, 100, 101, and that is the binary number. Right? That's how you do the calculation. Okay, then so the other way. So if someone asks you to convert from this number is given 2, 3, 7 in octal, they are asking you hexadecimal number. After giving this one, they are asking hexadecimal number. Then how you convert? You first convert this to binary. 2 means 0, 1, 0. 3 means 0, 1, 1. 7 means 1, 1, 1. According to this table. 2 means 0, 1, 0. 3 means 0, double 1. 4 means 1, 0. Then 7. 7 means triple 1. Okay. 0, 1, 0. 0, double 1, 1, 1. 1. This is in binary. Then you write 4 by 4. This 4 means this is F. The next 4, it forms 9. So number is 9F in hexadecimal. Hope you understood that. Let's do another one. Let's do another one. Right. Assume that you have a number like 7, 8, B, and they are asking you to convert this to octal. What is the easiest way? 7 you have to write in 4 digits because this is hexadecimal. Hexadecimal na 4 digit 7 kyanne 0, 1, 1, 1 here. 8 means 1, 0, 0, 0. Then B means 1, 0, 1, 1. Then you take 3 by 3. Then you take 3 by 3. මොකද ඔක්ටල් කියන්නේ 3න් 3 ගන්න ඕනේ. මේ 3 ගන්න Then 011 value will be 3, 001 value will be 1, 110 value will be 6, 011 value will be 3. 011 කියන්නේ 3, ඊට පස්සේ මෙතන 6, 1, 3, and that's how you convert this to octal. හරි, මොකක් හරි octal වලට convert කරන්න digit එකක් අඩුයි. For an example, you are given 1011 and asking you to convert to octal. Then මේ තුන ගන්න පුළුවන්. This tree will form 3. එතකොට මෙතන තුනක් නැහැනේ. Then you can add zeros to beginning. 001. 001 means 1, and this is the octal number. Hope you understood that. I have done a lesson actually, but I am not supposed to do because this is a revision class, because then if we are going to discuss theories much, then it will take more time. But since this is first day, I'm discussing this because this is very important. Some of you have missed the theories and easy ways, shortcuts, that's why I'm repeating. But next day itself I'm not doing this. The next day I'll discuss the paper without discussing the theory much. I'll discuss the theory but not much. Okay, let's come back to the question number 9, because we have discussed only 9 questions. You see, within 2 hours we have discussed only 9 questions, but we have done the paper, that is true, but discuss only 9 questions because we have to revise the theory as well. Okay, then question number 9. Binary form is used to store data and instruction in computer. Yes, very true, because you know that even the power button of the computer, you know the power symbol is, this is 0, and if this is 1, the power button of the computer is something similar to this. So you know it is 0, 1. So starting from that, because that is the easiest way to instruct a computer, electronic device, or electrical or electronic device. For an example, think about the bulb in your home, in your room. If you want to turn on bulb, how you pass message? Bulb එකට message එකක් තියෙන එකම දෙන්න තියෙන එකම විදිය, switch එකකින් on කරාම current එක යනවා, then bulb will on. Off කරන්න තියෙන විදිය, switch එක off කරාම current එක යන්නේ නැහැ, off වෙනවා. ඒතර off කරන එක 0, on කරන එක 1 නම් 1 0 වලින් අපිට bulb එක on off කරන්න පුළුවන්. So that is the easiest way. Okay, then right. So binary form is used to store data and instructions in the computer. That is true. A is true. Then 945 is a valid number in both octal and hexadecimal. Hexadecimal වල නම් valid, octal වල 9 නැහැ. දැන් අර decimal වල 10 නැහැ නේ. decimal වල තියෙන 0.9 වෙනකම්. 0 1 2 3 4 5 6 7 8 9. You don't have 10. In octal you don't have 8. 0 to 7. Hexadecimal you don't have 16. You have 0 to 15. So therefore this is wrong, because in octal you cannot see number 9. Then 412 is equivalent to this one. That is easily you can find. Now you know the method. 2 means 010, 010. 1 means 001, 001. Okay. 4 means 100. Therefore this is correct. A, C correct. Answer is number 3. Then the question number 10. Which of the following shows the storage component in descending node of access speed? Access speed එක අනුව descending node එක. Access speed එක වැඩිම එකේ ඉඳන් අඩුම එකට. අපි මේක කියවනේ pyramid එකේදී නේද? So this was our pyramid. We discussed about that. Access speed top to bottom. Descending order, registers, cache, DRAM, secondary storage, tertiary storage. So the answer is registers, cache, DRAM, hard disk. Registers, cache, DRAM, and hard disk means secondary storage. Answer is 3. Then if character E is represented in ASCII, ASCII means American Standard Code for Information Interchange. I said that everything in the computer should be represented in binary. Therefore there's a method, there's a way. So everything in a computer should be represented in binary. So therefore computer engineers, they suggested various methods to represent letters. So one method was BCD, binary coded decimal. One method was binary coded decimal. In binary coded decimal BCD, so you represent digits only. 0000 is 0, 0001 is 1, 0010 is 2, 0011 is 3, 0100 is 4, 0101 is 5, 110 is 6, 0111 is 7, 1000 is 8, and 1001 is 9. This is the BCD number system, binary coded system, decimal. But it can represent numbers only. This is 0, 1, 2, 3, 4, 5, 6, 7, 8. This is 9. Then if you want to tell a number, computer එකේ තියෙනවා නම් මෙහෙම number එකක් 2345 එයා රිප්‍රසන්ට් කරන්නේ දෙක කියන්නේ 0010 තුන කියන්නේ 0011 හතර කියන්නේ 0100 පහ කියන්නේ 0101 so එතකොට මේ සිග්නල් එක තමයි යා වයර් දිගේ යවන්නේ වයර් දිගේ යවන්නේ අතරම 10 යවන්න බෑනේ වයර් දිගේ යවන්නේ off off on off 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 on on off on off 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 on off on එහෙම නැත්නම් low voltage එකක් යනවා high voltage එකක් low voltage 3ක් high voltage 2ක් low voltage 1ක් high voltage 1ක් low 3ක් high 1ක් low 1ක් high 1ක් විදියට කරන්ට් එක යනවා ඒ යන කරන්ට් එකෙන් කියන්නේ 2345 කියන නම්බර් එක ඒක තමයි මේ binary coded decimal කියන number system එක ඊට පස්සේ මේක මදිනේ අකුරු ලියන්න ඒ හින්දා ආවා ඒගොල්ලන්ගේ FCD කියලා එකක් ඒකේ තේරුම extended binary coded decimal interchange code extended binary coded decimal interchange code ඒකේ 8 bit තිබ්බා. දැන් මේකේ කීයද 4 bit. 4 bit කියන්නේ කීයක් ලියන්න පුළුවන්ද characters? සමානයි 2 to the power 4 16 characters. ලියනවා නම් 16 characters තමයි ලියන්න පුළුවන්. මොකද මෙහෙම ලියා ගියොත් 9 පුළුවන්. තව 1010 10 1011 11 110 12 1101 13 1110 14 1111 15යි මේ බිඳුවේ එක්ක ගත්තම ඔක්කොම 16යි පුළුවන්. දැන් ඔයගොල්ලෝ දන්නවා මේක බිට් දෙකක් තිබ්බොත් කැරක්ටර් කීයක් පුළුවන්. බිට් දෙකක් තිබ්බොත් 2 bits 00 01 10 11. 2 bits තිබ්බොත් 4. 3 bits තිබ්බොත් 000 001 010 011 100 101 110 111 3 bit තිබ්බොත් 8 1 2 3 4 5 6 7 8 2 bit තිබ්බොත් 4 ඒ කියන්නේ දෙකේ දෙවෙනි බලය 3 bit තිබ්බොත් 8 දෙකේ තුන්වෙනි බලය 4 bit තිබ්බොත් 16 8 bit තිබ්බොත් දෙකේ අටවෙනි බලය what's the value it's 256 characters possible therefore EBCDIC was able to represent English letters meanwhile American Standard Code for Information Interchange was also introduced ASCII. ASCII represented 7 bits. Means it supported 128 characters. ASCII had 7 bits, so 128 characters. So there was something called extended ASCII, Extended American Standard Code for Information Interchange. It supported 8 bits, means 256 characters. Then there's something called Unicode. Unicode has 16 bits. 16 bits means how many characters? It supports like 65,000 characters. So you can calculate 2 to the power 16. 2 to the power 16. If you calculate 2 to its power 16. 2 to its power 16 basically 2 to the power 2 to its power 10 is 1024 but 2 to the power 16 is 65,536 this always double this always double 1024 then 2 to the power 11 is 2048 2 to the power 12 is 4096 13 is 8000 14 is 16,000 15 is 32,000 somewhere and 16 is 65,000. It always double. That's why you have 1 GB RAM, 2 GB RAM, 4 GB RAM, 8 GB RAM. That's why you have 1 GB pen drive, 2 GB pen drive, 8 GB, 1 GB, 2 GB, 4 GB, 8 GB. Always it use binary number system. It's a proof. Okay, now they're asking about ASCII codes. In ASCII codes, that was the question. Why I am discussing theories behind these questions? Because you will never get the same question, but we will get a question in the same format. Then if you know the underlying theories, එහෙම නැත්නම් ඔයාලට වෙන්නේ පේපර් එක පාඩම් කරන්න. පේපර් එක පාඩම් කළා වැඩක් නැහැ. පේපර් එකේ format එක සහ එකට දාලා theory එක මතක තියාගන්න. Then you can easily answer the question. Okay, ASCII character E was given. ASCII character E is they say 69. Then if E is 69, we can assume F is 70. Then if F is 70, G is 71. How 71 is created? What you have to do is you have to divide 71 just by 2. So then first time you divide it by 2, it will give you 35 remainder 1. 35 remainder 1 divide by 2, then you'll get 17 remainder 1 again divide by 2, then you will get 8 remainder 1, you divide by 2, then you'll get 4 remainder 0 divide by 2, you'll get 2 remainder 0 divide by 2 again, you'll get 1 remainder is 0, the value will be 1 0 0 0 1 1 1. The answer is number 2. Okay, then question number 12. So which of the following contains only task of an operating system? Operating system is the works between users and hardware. So basically any system software, ඕනම system software එකක් වැඩ කරන්නේ මේ මුලින් තියෙන system software එක, system software ඊට පස්සේ තියෙන්නේ hardware, ඊට උඩින් තමයි application software තියෙන්නේ, ඊටත් උඩින් තමයි users ලා ඉන්නේ. users ලාට basically මේ දෙකම access කරන්න පුළුවන්, application software, system software දෙකම users ලාට access කරන්න පුළුවන්. So what really happened when I save this document? What really happened? මම මේකේ file save as ගිහිල්ලා මේ document එක save කරනවා. But actually you don't know what's really happening. But if you think මේ වෙලාවේ මගේ hard disk එක magnetic hard disk එකක් නම් hard disk එකේ head එකක් තියෙනවා. That head should go and change the magnetic fields in the hard disk, and that's how the file is saved. If I'm going to save this in a pen drive, it should change the structure of the pen drive, the solid state memories or the pen drives. It should change the structure of the pen drive. But you cannot see that. Users cannot see that. That means these system software, these are hiding the internal complexity of hardware, because you cannot see the complex hardware process. Assume that you are writing this through CD, burn karna කියලා කියන්නේ CD එකට burn කරනවා, write කරනවා. What's really happened? There's a laser bulb. According to your binary signal, this laser bulb will be on, off, on, off, on, off, on, off වෙලා මේ විදිහට යනවා. එතකොට මේ laser bulb එක on වෙනකොට අර CD එකේ තියෙනවා aluminium හෝ platinum හෝ gold, Al, Pt or Au layer එකක් තියෙනවා, තුනී layer එකක්. මේ laser bulb එක පත් වෙනකොට අරක පිච්චෙනවා, burn වෙනවා. ඒ පිච්චෙන තැන් 1 විදිහටත් පිච්චෙන්නේ නැති තැන් 0 විදිහටත් එයා මතක තියාගන්න. ඒක තමයි CD එකක් burn වෙනවා කියන්නේ. නැත්නම් අපි කියනවා පිච්චෙන තැන් pits කියලා, burn පිච්චෙන්නේ නැති තැන් lands කියලා කියනවා. That's the CD burning process. You give 3, 2, 4, 5, computer will convert that to binary. That binary will go to the laser bulb. Laser bulb will turn on and off according to that binary signal. That will be written into the CD by burning the aluminum, platinum or gold layer. So that is a complex process, but you cannot see that because system software is hiding that internal complexity. එතකොට operating system is of example for the system software, and operating system is example for system software, and OS is we call resource manager. So it can manage resources. What are the resources? It can manage hardware resource. Any hardware resource it can manage. Not only that, system software is here, therefore it can manage applications as well. Because this is the middleman. It can manage this side, it can manage this side. System software can manage hardware, can manage application software. I said that users can access application and system software both. Therefore, system software can manage users as well. Whatever management process related to hardware. Process management is hardware. Payroll management, it's not hardware, it's not software, it's not even users. So it is wrong. Process management, hardware. Database management, it's not hardware, right? It's not database, it's application software basically, but this is lightweight. The database, it should not be managed because you have separate application software to manage that. File management, yeah, that is related. File management, because file should be managed by the operating system. Process management, true. Memory management, true. Database, again, it should be managed by application software. Process management, true. Memory management, true, because both are hardware components. Then file management. File is also reside inside the hard disk, so which is related to hardware. So number 4 is correct, related to the operating system. Then which of the following techniques can be used to increase the free space of hard disk without deleting existing files? They are asking about a private bus. Not actually. I was just kidding. So why I'm telling like that? So hitanna then you cannot delete. Without deleting, you cannot delete. You can remove people. You are in a private bus. You cannot remove people. Now you are the conductor. You are asked to get some more by your driver or the owner. They asked to get some more. So මොකක්ද ඔයා කරන්නේ? ඉන්න මිනිස්සුන්ව තල්ලු කරලා කොහොම හරි පස්සට යන්න සීට් අතරින් යන්න රොයි මේවයි කියලා. You compress the people. You put ඒගොල්ලෝ ඉන්න ඉඩ තව ලං කරලා you compress. After compressing that, you can put new files. So that's what they're asking. So in the hard disk, how to put a new file? Just by compressing. Copying some files in hard disk to flash drive. I can ඔයාගේ බස් එකකින් වෙන බස් එකකට දානවා වගේ. That is not going to happen. Formatting the hard disk. ඉන්න ඔක්කොම අයින් කරලා දානවා. ඉන්න ඔක්කොම මරලා දානවා. That's not going to happen again. Formatting means you kill everything. You delete everything, but it's not going to happen. Then partitioning the hard disk. You divide the current hard disk to small parts. But that doesn't help. That will be helping in management. If you have 2-3 conductors in the bus, you can do that. But that's not relevant to this one. No? So without deleting files, how you are going to take? By compressing. Okay, then we have a few minutes remaining. Let's discuss this quickly. While editing a document in the word processing software, you decided to copy selected part of the document to another document. Copy nam mokadda? Control C and paste Control V. So question number 1. So answer is number 1. Copy Control C, paste Control V. Mama explain kara. Control N new. Control P print. Control V paste kalla copy karanne nahi. Copy kalla paste karanne. So number 1 is the answer. Consider the range of cells given in A3 to C4. Cell range එකක් දුන්නොත් අපි කරන්න ඕන අපි ඇඳ ගන්න ඕන හිතෙන් ඍජුකෝණාශ්‍රය A3 ඉඳන් C4 වෙනකම්. පල්ලෑ තියෙන එකෙන් අපිට කරගන්න පුළුවන්. A3 කියන්නේ මෙතන. A3 ඉඳන් C4 වෙනකම්. ඒ කියන්නේ මෙතනින් පටන්ගෙන virtually ඇඳ ගන්න ඕන ඍජුකෝණාශ්‍රය. Okay. A3 to C4. Okay, what are the cells covered? So you can see this range. What are the cells covered? A3, B3, C3, A4, B4 and C4. A3, B3, C3. So how you are taking this A3, A3, B3, C3, A, then the 4, B4 and C for all, that is 4. The answer should be 4. Consider the following spreadsheet segment with formula B2 into $5 written in cell C2. B2 into B dollar. Why you are putting dollar? So dollar is required when you want to fix something. So when you put dollar in any spreadsheet, when you put dollar, what will happen? So I'm using spreadsheet. I'll show you this. Okay, assume that you have some numbers 4, 5, 6, 7. Right. If I want to add these two, I'm going to write this here. If I'm going to add A2 plus, you can see here, A2 plus A3, right? If I copy and paste formula here, it should be 9. Why? It will automatically copy the formula. Here my formula was A2 A3. A2 A3 relate වෙලා තමයි මේකේ උත්තරය ආවේ. එහෙමනම් මම එකක් මෙහෙට ගෙනියනවා කියන්නේ එතනදී දැන් මේකට රිලේටඩ් මේ දෙන්නනේ. එකක් දකුණු අතට ගෙනියනවා කියන්නේ මේකට රිලේටඩ් වෙන්නේ එතන උඩ ඉන්න දෙන්න. මම තව එකක් ගෙනිච්චොත් මෙතන කොපි පේස්ට් කරන්න නැතුව මෙතන තියෙන අර solid plus එකෙන් ගෙනියන්නත් පුළුවන්. හරි. දැන් මොකද්ද? It should be C2 C3. Here D2 D3. That means letter is changing. When you drag horizontally or when you copy a formula horizontally, letters are changing. Here A2 A3, B2 B3, C2 C3, D2 D3. But if I put a dollar in front of the letter, I'll put dollar in front of A. Okay, I'll put in front of 1A. So rather than changing both, I'll put in front of 1A. Let's increase the font size a little. Okay. Now you can see inside, in front of this A, you have dollar. Then if you drag this formula, you'll get different answers. If I check this, you can see dollar A is not changing. Here dollar A is not changing, dollar A is not changing, and here also dollar A is not changing, right? So if you put dollar inside some letter or dollar inside a number, that letter or number will not change. That is called absolute reference. Absolutely that one will remain. So same thing will happen here. So if I get equal sum of these numbers, if I drag the formula bar down, if I drag this down, this is sum A2 D2, the bottom one sum A3 D3. That number is changing. If you are dragging down, number is changing because this side number is changing. But if I put dollar in front of number and drag, then you can see the second one also $2, the first one also $2. Then number is not changing. If I put dollar inside this one also, this number will also not change. It will remain the same answer, same range, referring to the same range. If I put dollar in front of the letter and number both, then if I drag down, you can see always it is 22 because letters not changing, numbers not changing. If I drag this side, again you can see the same thing because letters are not changing and numbers are not changing. So that's how you create charts. Basically charts හදනකොට range එක දෙන්නේ dollar දාලා. ඒ dollar දාලා දෙන්න range හේතුව තමයි chart එක තනින් තැනට ගියාට change වෙන්න එපා කියන එක. So static referencing will be given by using dollars. Relative referencing will be given without using the dollar. So here what has happened, they have used static referencing for $5. $5 means this one is not changing. This one is not changing, but B2 is changing. If you drag this or copy this to this one, B2 we change to B2 පල්ලෙහාට copy කරොත් change වෙන්නේ මොකද්ද? Number එක. B2 change වෙනවා B3 වලට. B3 into B$5. B3 60යි 60.1කින් වැඩි වුණාම 6000යි. So answer is number 3. Okay, you want to add a black slide. This one I discussed. It is Control M. And which of the following features of electronic representation can be used to change the arrangement? මෙතන තියෙන arrangement එක මේකට ගන්න මේ වෙනස් කරලා තියෙන මොකද්ද? Layout එක. This is slide layout. Slide show එකෙන් කරන්න පුළුවන් slide එක පෙන්නන එක. Slide sorter views කීපයක් තියෙන. Slide sorter කියන්නේ slide thumbnails වගේ පොඩියට පෙන්නන එක. Slide view එකේදී normal අපි edit කරන view එකෙන්. So this can be changed using slide layout. So which of the following is not common features to both word processing and electronic presentation? දෙකේම නැත්තේ මොනවද කියලා අහන්නේ. So I'll stop from today, this one for today because time is up, and let's discuss the next thing next day because I have another class to be started. That's why I'm stopping. So if you have any question, you can send it to Edmodo. After question number 19, the paper will be finished by next week. Maybe if I have time, I'll discuss this before that and publish in Edmodo. Right, if you have any question, you can WhatsApp or you can use Edmodo LMS to send it to me. And there's an exercise. Please go and complete that. There's assignment. 5 questions are there. Please go and complete that as well.